Alright, in video 3 we're going to talk about empirical molecular formulas. Empirical formula is the simplest formula, which means you could not reduce your subscripts. Molecular is not the simplest formula, simplest ratio, so the subscripts can be reduced. It is some factor bigger than the empirical. So first let's make sure we can distinguish the difference. And so this one, C2H4, 2 and 4 can be divided by 2, and so this is a molecular formula because it can be reduced. 1 and 1 is the simplest ratio, and so that's empirical. Okay. 11, 12, and 22, that too is the simplest ratio of those numbers, and so that is an empirical formula. Right, and so next we're going to look at how to find the empirical formula of a compound. And so percent composition is usually given to us, and we assume that we have 100 grams to make our math easier. And so basically there's a little poem you can use. Mass to mole, divide by small, and multiply till whole. Alright, so we need a mass. If we assume 100 grams of our compound, we have 100 times 25.9% gives us 25.9 grams of nitrogen, and then we get 74.1 grams of oxygen. And so our first step is convert our mass to moles. And so our grams will go on the bottom, moles on the top. 1 mole of nitrogen has 14.01 grams. And so when we divide, we find we have 1.85 moles of nitrogen. And then we'll do the same for oxygen. 1 mole of oxygen has 16 grams. And so we have 74.1 divided by 16 gives us 4.63 moles of oxygen. So that's the first step, mass to mole. Then we divide by small. So we divide by the smallest number of moles. And that's going to give us a ratio of nitrogen to oxygen. And so since nitrogen is our smallest, we're going to divide by it, in which that tells us that we have 1 nitrogen and we have 2.5 oxygens. So that's our ratio, 1 nitrogen to 2.5 oxygens. We don't write formulas though as NO 2.5. We have to have whole number ratios. And so this is where our last step comes in. How do we multiply till whole? So how can we keep this same ratio but make it a whole number ratio? So if we have a 0.5, we would multiply both things by 2, and that keeps the same ratio. We've just doubled everything. And so that means we'll have 2 nitrogens and 5 oxygens. So the formula would be N2O5. So that would be the empirical formula. Another way we could calculate the empirical formula is if we're given the mass. Right? So in this problem, instead of being given percentages, we're given mass. So we still follow the same steps. We take our mass and convert them to moles. So we have carbon, which has 12.01 grams. And we find that that would be 0.445 moles of carbon. And we'll do the same for hydrogen, 0.42 grams. And so 1 mole of hydrogen is 1.008 grams. 0.42 divided by 0.008 gives us 0.417, or 42. We only had 2 significant figures there, right? 42 moles of hydrogen. And then 47.08 grams of chlorine. Chlorine is 35.45 grams for 1 mole. And that gives us 1.328 moles of chlorine. So we changed all of our masses to moles. Next we divide by small. So what's the smallest number of moles? So we'll divide by 0.42. 0.445 divided by 0.42 gives us 1.0, and then we have 0.42 divided by 0.42 is 1, and we have 1.328 divided by 0.42, and that gives us a 3.2. Okay, and so next we need to multiply till whole. So how do we multiply these until we have a whole number ratio? So what fraction is 0.2? Alright, that'd be 5. So we would multiply each of these by 5. And so we'd have 5, 5, and then 3.2 times 5 will be 16. And so we would get, I can run out of room over here. Let's see if I can. So we have 5 carbons, 5 hydrogens, and then 16 chlorines. Okay. Number 3, looking for the molecular formula now. So for the molecular formula, it's some number of times bigger, some factor, and I'm going to call that factor n. Okay. So we need to find our n. To find our value of n, we need the molecular mass, or the molar mass, of the compound divided by the empirical formula mass. Okay, and so here we get 60 grams per mole is our molar mass, divided by the mass of our empirical formula. So we add up this mass. We have 1 carbon is 12.01, plus 4 hydrogens, each at 1.008, plus 1 nitrogen is 14.01, and we get 30.05. So when we divide those, we basically get 2, which means that our molecular formula is twice as big as our empirical. And so we just multiply all of our subscripts in our empirical formula by 2. So 2 times 1 is 2, 2 times 4 is 8, 2 times 1 is 2. And so that would be our molecular formula. Okay. So let's look at one more problem. What's the molecular formula of a compound whose molar mass is 204 when the empirical formula is that? So we have 5 carbons, so 5 times 12.01, plus 10 hydrogens times 1.008, plus 32 for our 2 oxygens gives us 102. And so again, we divide and we get a 2. Now, it's not always going to be 2. This just happens to be the case in this problem, right? And so we're going to then multiply this coefficient, this value, this factor, by all of our subscripts. So we have 2 times 5 gives us 10, 2 times 10 gives us 20, and 2 times 2 gives us 4. And that is our molecular formula. Okay? So I want you to pause, and then I want you to try the next 2 problems, and then come back and we'll look at them together. Alright, so in the first problem we're going to find the molecular formula. The mass is 304. We want to divide then by the empirical formula mass. This is the same one we found earlier, was 102. When we divide these, we basically get 3, right? And so it's 3 times as big, so it's C15H30O6. Right, because 3 times 5, 3 times 10, and 3 times 2. Right, and the next one, we're going to determine the molecular formula of a compound that's 56.38% phosphorus and 43.6% oxygen, and has a molar mass of 219.9. Well, first we need to find the empirical formula. So we take our masses. Remember, we just use our percentages as a mass. So we have 56.38 grams of phosphorus, and then 43.6 grams of oxygen. Alright, remember our poem, mass to mole. So we convert our mass into mole. So 1 mole of phosphorus has 30.97 grams, and 1 mole of oxygen is 16 grams. Alright, so we convert to moles, and we get 1.820 moles of phosphorus, and we get 2.73 moles of oxygen. So then our poem, mass to mole divided by small. So now we divide by the smallest number of moles, which is 1.82. So this is a 1, and then 2.73 divided by 1.82, we get 1.5. Again, then we have to multiply till whole. It's our last phrase of our poem. So how do we make this a whole? We multiply by 2. And so we would get 2 phosphorus and 3 oxygen. So P2O3 would be our empirical formula. But we want to find the molecular formula if that's the mass. So now, how much bigger is that than our empirical? So we have 219.9 divided by the molecular formula of this. The molar mass of this empirical formula. So we have 2 times 30.97 plus 3 times 16 gives us 109.94. And so we take 219.9 divided by that answer, 109.94, and we get 2. Right? And so our molecular formula is going to be 2 times larger. So 2 times 2 is 4, 2 times 3 is 6. So P4O6. And that's how we find molecular and empirical formulas.